Good day, everyone. And once again, we are back together. And this time we'll be looking at financial maths. And this is the 2021 May June exam. If you haven't subscribed, please just make sure you are part of the family. And of course, you are most welcome to hit the like and share button at the end of this lesson. We'll be continuing running this series right up until you guys write your exams, and we'll be alternating between mathematics and physical science. Okay, so let's look at financial maths this time around. It's question 7. As I said, of your May June exam in 2021. Now they say to us, we've got an amount of 10,000 that was invested in 4 years, earning interest at a rate of R% per annum. Okay, and they say it's compounded quarterly, and at the end of 4 years the total amount in the account was 13,080. They say we should determine the value of R. Okay, so we want that interest rate in this case, or the amount of interest. Okay, so actually I'm correct, the interest rate. Okay, so we are going to look at 7.1. Now please remember, they did tell us this is compound interest, right? So of course, we're going to use our compound interest formula. That's A is equals to P 1 plus I, obviously to the power N in this case, right? Now, what they told us rather is that the amount accumulated to an amount of 13,000. So we know that our accumulated amount is 13,080. Our principal amount in this case was 10,000. Okay, and we know that we are now compounding quarterly. Okay, so we know this is going to be 1 plus. Now please, I want you to note, we always say over n m in this case, which is the period of compounding. So we're going to say this is I over 4, right? And in this case it's 4 years. Okay, and of course we are compounding quarterly, so we are multiplying that by 4. All right, now we're going to try and solve for this. Of course, we're going to first of all divide both sides by 10,000. Okay, so in this case, I am left with on this side I, or rather 1 plus I over, I'm not sure why I keep writing that incorrectly, I over 4. This is to the exponent of 16. Now, what I'm going to do is just leave this as is. That's 1380 over 10,000. And I would sincerely ask you, ladies and gents, to try and work on your calculator as much as possible without initially rounding off. So how do we remove this exponent here? We're going to take the 16th root, okay? So we're going to take the 16th root of that, okay, so that we remove this. So on the other side, we've got 1 plus I over 4, okay, and of course we're going to subtract by 1. So I'm going to do that in the calculator. I am going to take shift, so I'm going to take the 16th root of this value that's inside here, and that is going to be 13. So that's 13,000, and so that's 13,080, right? Oh no, actually now I'm making a mess of this. So that's 13,080, and then that's divided by, okay, so that's divided by 10,000. Okay, all right, so I get that value there. In this case, it gives me 1 point, or whatever that value is, and I'm going to now say that subtract 1. So remember, we've got this one here. I'm going to subtract 1, okay, and I am going to multiply by 4 So multiply that by 4, I get 0.06. But remember, in this case, we want the interest rate, so we still need to multiply that by 100 so that we get the correct rate. So in this case, I've got I is 6.77. Okay, so that's going to be 6.77%. I'm sure you can work through that and obviously find that answer for yourself. All right, now let's go on to the next one. So they say a businesswoman deposited 9,000 into an account at the end of January in 2014. She continued to make deposits, monthly deposits of 9,000 at the end of each month at the up to the end of December 2018. Okay, the account earned interest at a rate of 7.5% per annum, and that's compounded monthly. All right, now I'm sure you can see this is obviously we're looking at annuities here because we are depositing, a fixed amount on a monthly basis. Okay, so in this case, they say calculate how much money was in the account immediately after 60 deposits had been made. All right, so that is going to be quite straightforward. So that's 7.2.1. Okay, so what we did there, so we know that we are depositing, in this case, a fixed amount. So this would be on month 1. So I'm assuming, so this is at the end of January, right? So that's at the end of January. So if we think about it, so this is January 2014. Okay. Yeah. Right up until December in this case. So this is December in 2018. Okay. And of course, they made it easier for us by telling us that that's going to be 60 deposits, right? So we know that we're just going to go straight forward into that. Okay, so we are looking into our annuities formula. So that's X into 1 plus I exponent n minus 1. Okay, and that will be divided by I. Right, so we know that we are depositing an amount of 9,000 on a monthly basis. Okay, so 1 plus our interest rate, they said this is 7.5%. But remember, in this case, we divide that by 100. 7.5 divided by 100 will give us 0.075. Okay, but now, please, I want you to note, remember we are, it's compounded monthly, so it means that we're going to divide that, by 12. Okay, so that's divided by 12. Okay, and it's 60 months all in all, right? If they had said to us 5 years, so we're going to say 5 multiplied by 12, which gives us 60, right? So that's minus 1. Please just be careful there. And this would be divided by 0.075 divided by 12. All right, now we're looking at that future value there. Okay, let's try that. So we're going to say 9,000. Okay, I'm going to open 2 brackets there. So 1 plus 0.075 divided by 12. Okay, and yx. Okay, 60. Please just remember in this case to take the cursor down. So that's minus 1. And that gives me this value. Okay, if you want to, you can say equal to. And we're going to divide now by the denominator, which is 0.075 divided by 12. Okay, and I get an amount of 652,743.95. Okay, so it means that our future value will accumulate, of course, into that value over there. All right. Hopefully, we were able to get to that. Now, let's get to the next question. They say the businesswoman left the amount calculated in question 7.2.1 for a further n months in the account. Okay? All right. So, obviously, at month 60, she's now made so many deposits, and then at month 60 she leaves that amount, which is the 652, for, obviously for a further period, which obviously we don't know what that period is in this case. And now they say to us, okay, right, the interest rate remained unchanged. So we remember that we still have an interest rate of 7.5% per annum, and just remember that it's compounded monthly, right? And then they say no further payments were made. The total interest earned over the entire period, okay, was 190 and 214 cents, right? Now, in this case, they want us to determine the value of n. Now, we just need to be a little bit cautious here, because remember, now 190 would be the interest that is earned over this entire period. Okay? So in this case, we need to find out, so what I'm going to do is, let's take the 9,000, okay, and find out in this case, how much the value of the deposits were, right? So over the 6 months, you've got the value of the deposits, which would have earned interest, that accumulates to this amount, okay? So in this case, we're obviously going to find that amount, or rather take that amount, and then I want you to really think about it. So the 190, remember, 190 is the interest that is earned over this. Now, what we're going to do is take that amount. Now, this becomes our, you can take it as the present value, okay, at the 60th month. And now we're going to deposit it, and it's going to earn a further interest, okay? I want you to really think about that. So let's start with this period over here, right? And say, all right, so we've got a deposit. So we deposited 9,000 rands, okay, over a period of 60 months, okay? So let's find that out. So that's 9,000 multiplied by 50. So your deposits amounted to a total of 450,000 rands, okay? Right, now there's an approach that you can take where you can actually calculate that interest, but I want to just take a sort of a different approach to this, and I'll show you another approach later on, right? Now, right, so this is the amount of deposits that were made, right? So if you think about it, so the interest in this case, that the total interest that has been earned was 190,214.14 right? So this amount plus the amount of deposits, the interest plus the amount of deposits, right? 214.14 would be the total amount in this case, that accumulated over the period, of time, or rather in this case, that would be the total amount that accumulated over that period of time, right? So in this case, what I'm going to say is, so now it means that over and above, now let's find out how much that amount is. So that's 450 plus 190,214.14. Okay? Right. So, no. I think I made an error here. Okay. Yeah, so that would be 450,000. Okay. Yeah. No. I think I just did something wrong there. So if I said 9,000 multiplied by 60, yeah, I can see that something looks amiss because I was getting a value that is actually less than that amount that accumulated there. Right, so in this case, that gives me a 540,000. Sorry about that. So that's 540,000. Okay. And then I'm going to add the interest that accumulated over the entire period. Okay. So this is plus 190,000, 214 and 14 cents. Okay, so this amount gives me 730, 214 and 14 cents. So this is the entire amount that accumulated in that account over the period, right? Okay, so now I want you to think about it. So this amount here would be, now I'm going to take this as my present value over here, right? So that's the present value. So over this period of time, how much would that period be so that the total accumulated amount over the period is 730, 214 and 14 cents. I hope that makes sense, right? Because remember, when this amount was left over the period of time, right, it accumulated to this amount. So this is the total deposits plus the interest that was earned over this time, right? But when we leave it, it then accumulates to this amount here. So what I'm going to do is I'm going to use my A is equals to P, my compound interest formula, right? In this case, so my total accumulated amount is 730, 214 and 14 cents, okay, which is equal to, I'm going to take that amount that we had over the 60 months, so 652,743, okay. Was there, yeah, and 95 cents. I remember that there were some cents there, okay. And in this case, that would be 1 plus. Now remember the interest rate, they said to us it remains the same, okay. And we know that this is over 12 months, right? Okay. And in this case, this would give us the amount of months that they are, right? That we deposited this amount here. Right. So in this case, I'm going to divide by that amount, 652,743.95. And what I do on the left, I do on the right, 652,743.95. Okay. And I want you to note in this case, I would now take the log on both sides. So I'll take the log of that entire thing over there, right? So the log of that, and I'm going to introduce the log of this. This is me just being lazy, okay? Why do I want to do that? Remember, once I take log of that whole thing, 1 plus 0.075 over 12, right? In this case, exponent n. So remember, with logs, I can drop down. Okay, so this becomes n log of that entire thing, and I can divide by that, right? 7.5 over 12. Okay, now we can divide by that whole thing over the left hand side, but I can do the same. Okay, I'm going to take that whole thing there and divide by the same log of 1 plus 0.075. And please just try and avoid writing a whole lot of things, lest you make an error, right? So I'm just trying to show you how we're going to do that mathematically. but in this case, you don't necessarily need to write it down. Okay. Right. So in this case, let's just quickly try and work it out on, sorry, this is divide by 12, not n. Okay. So now I am going to take the log of that. Okay. So I'm going to take the log of 730,000. So that's 730,000. 214 and 14 cents divided by no, that's divided by, okay, remember the 652, okay, 652, that's 743, that's 743 and 95 cents. Okay, so that's just on my left hand side, right? Okay, so we get that amount, and now I'm going to divide by, so divide that whole thing by the log of, this is 1 plus 0.075 divide by 12. Okay, right, can you see I get a value of 18? So that means that this will be 18 months. Okay, right, so it means that it was deposited over a period of 18 months. Right, there is another approach to this that I would like for you to just consider. Just think about that. Okay, you know, if you think about it, so we draw that timeline. So we know that we were making deposits of 6,000 rand, or of 9,000 rather, okay, over that period of 60 months, right? Now, what we can do is we can find out how much interest was earned over this period. Now, you remember the total accumulated amount was 652, I think 743.95. Okay, so we can find out how much interest was earned over this period, right? How do we do so? We find the amount of deposits, right? Remember, we said 9,000 multiplied by 60. We got that 540,000. I hope you still remember that, right? So how much interest was earned over this period? Okay, we subtract that amount from this amount. So you can say the interest in this case over that period of 5 years was going to be 652,743.95, okay, minus the 540,000. Okay, let's just find that quickly. Okay, so that's 652, okay, 743.95, that's minus 540,000. Okay, that gives me an amount of 112,743.95. So this is the amount of interest that was earned, right? Now, remember the total amount of interest that that was earned over the total period. You remember that amount that they gave us, 190,000. Okay, so we can subtract that to find out the interest that accumulated over just this period where we left this amount in the account. Okay, so I can say, well, the interest in that case over the period in question would be 190,214 and 14 cents minus this interest over the period of 5 years, 743.95, right? So we can say, I'm just going to say this is minus 190, 214.14, okay. I get an amount of 77,470 and 19 cents. Now, this is the interest over this period where we left this amount over those months, right? That we didn't know. Okay, so now I want you to really think about it. So it means that the amount that accumulated over this period would be this principal amount. We're taking this now as our principal amount plus the interest that was earned, right, which is the 77,000 and the one that we got over there. So I'm going to say, right, so it means, please, I'm not going to continue with that. Né? So it means if I take my accumulated amount, principal amount, this is over the period, right, over n, and in this case we can say n times m. In fact, I'm just going to leave that as just n, right? So if I just take that, so my accumulated amount would be the 652,000, okay, that was accumulated, I think in 95 cents, right? And then plus that interest there over that period, 470,019 cents. This would be equal to, so this would be the accumulated amount. This would be equal to the principal amount would have been the 652,743.95 over that period, right? So in this case, so what I'm going to say, this is going to be 1 plus, remember that was 0.075. I'm trying to squeeze in that value there. That's over the 12, over 12. And in this case, I'm just simply going to look for n in that case. And of course, I'm sure if you work it out, you would still get to the same value. Please just confirm with me if it does give you the same value. And of course, I'm quite certain that it will do so. I hope that was perfectly understood, ladies and gents. And that is how the cookie crumbles, This is quite a nice section. You can pick up quite some marks on this one. And of course, if you haven't watched our series on financial maths, please do so now. Okay. Otherwise, I will see you again next time. All right. Hope you keep yourself locked on this channel. Next time. Sharp, sharp.